Good morning, Science 10s. Here is our second video on EP, Potential Energy Notes Guide. So last day we talked about the definition of potential energy, the potential or ability to do work, and we talked a little bit about gravitational potential energy, the difference between mass and weight, how to do some calculations of that. And here's where we left off. We have some example problems here that I would like to do with you guys. Remember, when you are doing your problems, you write out your formula. Even before you do that, read the question, write out all what you have given and what you're looking for. Again, there's no marks for that, but that helps you to organize your answer. Once you've got your formula written out, some are going to be easy. Example problem B 2.1 here is just a straight plug and chug. So EP gravity is what we're looking for. What is the potential energy? We're given the mass. That's 3 sig digs. We're given the height. That's 3 sig digs. We're on Earth, so we know gravity. This is in your data booklet given to you. 3 sig digs. Write out your formula. Plug your values in. Here's my mass, including units of kilograms. Here's my acceleration due to gravity in meters per second squared, 3 sig digs. Here's my height, 1.50 meters, 3 sig digs. Do the math on your calculator, plug it in. 3 times 9.81 times 1.5 is 44.1 kilograms meters squared per second squared. Now remember, this is a derived unit. What is a kilogram meter squared per second squared? It's a Newton meter or a joule. Remember, this is energy. Energy is measured in joules. So the potential energy due to gravity that this box has, because it's above the Earth's surface, this ability or potential to do work is 44.1 joules. So here's my final answer. I've got sig digs. Yes, I do. I've got 3 sig digs. Units of joules. I didn't need to round it. My calculator just showed me 44.1 joules. And now if I want, I can always put it into scientific notation. I could go 4.41 times 10 to the 1 joules, totally acceptable. Or you can just leave it as 44.1 joules. Easy, plug and chug. Now, not all of your questions are going to be quite so easy. This next example, you have to rearrange this one and solve for the height. So a little bit different here in that we're given the potential energy due to gravity. We're given the mass. We always have gravity on Earth, the acceleration due to gravity, 9.81 meters per second squared. That's in your data booklet. Page 6 if you're not sure where to look. And so in this example, you are actually given everything except the height. So you have to rearrange the formula and solve for the height. And when you do that, then you get EP grav over mg. Plug your values in. Now, look at this. There is nothing to cancel here. If I just put in joules divided by kilogram meters per second squared, nothing to cancel. That's why you must convert that into its derived units. Kilograms can now cancel. Meters squared over meters, one of the meters cancels. That's how we end up with meters being our final unit, and seconds squared will cancel. So I'll do another example like this, but understand that some of these you're going to have to rearrange, and always write your original equation down just in case you mess up in your rearranging, and then you will still always be able to get full marks. So let's do a couple of practice problems. We've got 3 here on the next page. So let's start reading through what is it that we've been given. Okay, in this question, we have a child with a mass. Okay, so here's the first thing. The mass is 25.0 kilograms. How many sig digs? 3. And they're at the top of the slide in an amusement park. So they've got potential energy because of their height. Well, what is the height? The height is 4.00 meters, also 3 significant digits. So what do we have to do in this question? Here's where it says right here, calculate the gravitational potential energy. So EP grav, that's what we're trying to find. This is something going to be in joules. And, wait a minute. They've given me mass and they've given me height. I thought the formula for this was EP grav is equal to mgh. Well, how can I solve this? Don't I just have mass and height? You always have gravity, right? You are on planet Earth, and so gravity is given to you in your data booklet. So if you forget, it's on page 6. If this was like on Mars or something, you'd be given that value for gravity, okay? But because we're on planet Earth, you just look it up in your data booklet, and boom, it is 9.81 meters per second squared. Okay, great. Now that everything is written out, we're writing out our formula, EP grav, mgh. We do have everything there. We've got the mass, we've got the gravity, and we have the height. So what do we do now? Go and substitute in your values. 25.0 kg, there's 3 sig digs there, times 9.81 meters per second squared. That's from my data booklet, or I've got it memorized. And my height is 4.00 meters. Okay, so once I've plugged it in, and don't forget to show all your units, kilograms, meters per second squared, meters. Then once that is done, do the math on your calculator, 25.0 times 9.81 times 4, and you get a value of 9.81 kilograms per meter squared per second squared. That is not your final answer. Sorry, I think I said the correct units there was kilogram times meter squared per second squared. Sorry if I said that wrong. So this is not your final answer yet, right? You have to understand that this is a made up unit. And so what is the equivalent unit? Well, this is an energy term. So my EP due to gravity is 981 joules. So there, joules is what I use for energy. Now check your answer. Do you have the right number of sig digs? Yes, I've got 3 sig digs. And I've got units correctly of joules. I didn't have to do any rounding because my calculator just told me that. It was good to go. You can always put it into scientific notation if you want. So let's say you wanted to do scientific notation for this question. You just move your decimal over 1, 2 spots. So an equivalent, also same marks. You would still get full marks for this. 9.81 times 10 to the 2 joules is equal to the potential energy due to gravity. Totally full marks for this as well. Okay, you can leave it here as 981 joules, and yes, you would still get full marks for that. All right, so there's our first example problem. Easy peasy. This is a plug and chug. All right, we had everything given to us except EP due to gravity. Now let's look at our next question. In this one, we have the mass, it's 800 grams. This one, we're given the EP due to gravity, 47.0 joules. Now, in order to do your canceling out of units, you have to show the equivalent. Remember, this is derived. It's kilograms, meters squared per second squared. That's the same thing. And it says calculate the bird's vertical height. Height is what we're looking for. Now, a lot of you think, oh, well, I just got mass and I just got EP due to gravity. You have one other thing. You're also given gravity due to the acceleration on Earth, right? So G in your data booklet, 9.81 meters per second squared. You always have that because you've either memorized it or it's in your data booklet. Okay, let's do what we normally do. Write out our formula. EP due to gravity is equal to mgh. So this time we have the EP due to gravity, we have the mass, and we have the height. So we actually have to rearrange and solve. Sorry, we have gravity. We don't have height. We are looking for h. That's what we need to solve for. Okay, so this equation is not just a plug and chug. We have to rearrange and find h. So let's do that. EP due to gravity. And just to make it easier, I'm just going to write EP. It's mgh. So we have to get h all by itself. And that means to do that, we have to get rid of everything else on this side. So it's m times g times h. The opposite of multiplying is divide. So we're going to divide out mg on this side. That will cancel mass. That will cancel gravity. Now we're left with height. But don't forget that if you do something to the right side of the equation, we have to do the same thing to the left side of the equation. So I am left with the potential energy due to gravity divided by mass times gravity. Okay, so now that we've got this rearranged, and again, always write out your original formula, then rearrange. Okay, if you don't write out your original formula and you rearrange incorrectly, you get no marks. All right, so at least you get part marks for writing out your formula and for rearranging. So once you've got your formula rearranged, and you've got EP due to gravity divided by mass times the acceleration due to gravity. You've got to then substitute in your values. And don't forget units. So we have to convert from joules to our basic units of kilograms, meters squared per second squared. And you can see that once you do that, now you can cancel out kilograms, seconds squared cancel out, and then you've got meters squared divided by meters. Remember, meters squared is the same as meters times meters divided by meters. So one of them cancels, and what are we left with? We're left with units of meters, and that makes sense for height, right? Height in meters, fantastic. That's what we wanted to get. And so on your calculator now, 47 divided by, use your bracket function, 0.8 times 9.81. And again, as I said, cancel out your units. And with your rounding, sig digs, scientific notation, correct units, height is 5.99 meters. So my calculator showed me that my value is 5.9887 something, 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 right? And so to 3 sig digs, right? I got 3 sig digs here, 3 sig digs here, 3 sig digs here. My final answer is going to have 3 sig digs. So 1, 2, 3 sig digs. That 8 is going to make that round up. And my final answer will be 5.99 meters is the height that this bird is found up in a tree. Okay, so when you're doing this, make sure you've canceled out all your units and look and say, does it make sense? Is my height in meters? Well, yeah, that's what the units should be. 3 sig digs for my final answer, and we're good to go. In the last example, I'm actually not going to do this one for you. The key is posted, but I'm going to allow you to do it on your own. So again, write out what all do you have? Well, look and see. Here we've got a sign. It's hanging at a height of 3.00 meters above the ground. And it has a potential energy due to gravity. EP due to gravity. 1.47 times 10 to the 3 joules. And you are asked to calculate the mass of the sign. So remember, you actually have 3 pieces of information here. When you write out your formula, EP due to gravity, oops, my pen's not working very well. EP due to gravity is equal to mgh. Now, you have the height. You are looking for the mass of the sign. You have the EP due to gravity. You always have, because you're on Earth, you have the acceleration due to gravity. So don't forget that you have that. It's in your data booklet. So you're going to have to rearrange this formula. Instead of solving for h, as we did last time, you solve for mass. Once you have done that, plug all of your values into the equation, show all your units, plug them into your calculator, do your canceling, write your answer out with sig digs, units, rounding, and scientific notation. Okay, so remember, these keys are posted. It is up to you now to make sure you are on top of things and stay on top of your work. All right, that's it. That's all. Have a great rest of your day.